Good evening and welcome to another edition of Tetherless World Wednesday night. Yeah. Tonight we have Jim McCusker here, third-year PhD student from Massachusetts, right?
Connecticut.
Whatever. It's over there. Probably rooted for the Patriots too. I'm really sorry about that.
No.
No? All right. Anyway, we're going to be talking about D3.js today, visualization library. Jim, take it away. Thank you very much.
And that was Patrick, our graphic designer. Say it. Correct me.
What?
No, never mind. The rhythm is ruined. You're supposed to say programmer, and I say whatever.
Oh, senior software engineer.
Whatever. Okay, better. Okay, so this is actually a rebroadcast of a presentation that Mike Dewar has put together called Baby Steps in D3. You can get the slides at github.com/MikeDewar/D3Talk. This has been customized by me for semantic web based things. So we're going to be querying Sparkle endpoints with this stuff. Two facts. The first one is that D3 is a JavaScript library, and Mike Bostock is the guy who put this together. It's not actually a visualization framework. Well, not just a visualization framework. So what D3 actually stands for is data-driven documents, and actually that's kind of what we do in Tetherless is we work with data-driven documents. What this is a way of programmatically manipulating documents that exist in a web browser document object model and actually produce a new structure based on the data that it's being given. And this is actually we just queried our Tetherless Sparkle endpoint, and so those of you who know some of us will recognize some people in here, including me. But what this is a force-directed layout of where every person is a node, and basically all we did was we went out and queried the Sparkle endpoint, got back a list of people from it, along with their names and their pictures and their URIs, and just put it together. Now I'll explain more about what's happening in there because that's actually kind of key to this. So we're going to start with talking a bit about JSON, and also I snuck in a little bit about querying JSON or getting JSON back from Sparkle endpoints and doing it really easily in JavaScript. I'm going to be talking about using D3 selections and how you manipulate the DOM in your web browser. And I'll probably dip into using the Chrome developer tools just to show you what's happening behind the scenes. I'm going to be coughing a lot because I have a cold. And also we're going to actually use D3 as a visualization framework, which, yeah, kind of is, because there's actually a lot of pieces in there that are specifically designed for visualization, but not everything. So some of you know JSON already, some of you don't. They're key value pairs. You can have, so keys are always strings. Values can be booleans. They could be arrays of stuff. They could be numbers. They could be null. And then the same thing is true for each of the values. And so this big thing actually is one giant map. And so we actually have a bunch of key value pairs. But then you can also nest other maps within it. So basically, JSON is a combination of maps, arrays, strings, numbers, booleans, and nulls. Basically, it lets you describe a lot of interesting data this way. This is a bigger example where we actually have some data that's been pulled out of somewhere. But basically, there's a language that this record is encoded in. There's the city name. So this is, yeah, I should actually read this first. This is kind of a profile, so there's the zip, the city, the person that they live there, a little bit of bio, the country they live in, any topics, and other services. This actually works this is pretty similar to FOAF, to some of you who are familiar with that. But this is a JSON-specific version of it that doesn't actually, well, it doesn't have any semantics in it. But what we're going to do is we're going to show how to add those semantics by querying it out of triple stores. So one style rule, don't store data in the JSON keys. Number one, you're restricted to strings, so you're going to be stripping type out. But also, it's just bad. I mean, what is this? I mean, it's really, it's not self-documenting. You don't know what's going on here. So usually what you want instead is something like this. So, yes, that's a time. There's a values for it. And so you can see kind of a naive, JSON user would say, oh, well, it's just going to be a time series. I can encode the time and then the value for it and just go ahead. But it's much easier to understand what's going on if you actually bother to use labels. There's for checking JSON, you can use jasonlint.com, and JSON can be served from any conventional web browser. However, we have our data in much fancier forms. We have our JSON stored in Sparkle endpoints. So you can do things. So I've got this Sparkle script that actually takes care of some of these details if you're also using D3. But you basically say, here's an endpoint, here's a query that you want to use, and these backslashes are JavaScript thing. And then all you have to do is call Sparkle select the query, the endpoint, and the callback function, and you get back the result as this JSON object. And so actually, I guess I should say that one of the, as I said in the description for this talk, one reason why this is should seem interesting to other people is because I've avoided using JavaScript for 11 years. That's 11 years out of college, not 11 years like in high school and so forth. It's been a long time since I've known about JavaScript, since I've become familiar with it, and there hasn't been anything that's been really compelling for me to actually start using it until I've seen this. And so the elements of a visualization in D3 is the data, which normally you get to from JSON, but you can actually get to it from CSV as well, other formats. HTML, which controls the structure of the page. JavaScript plus the D3 libraries provide the layout and the actual construction of the data into visuals, and then of course CSS, which actually makes things look bearable. And so these four things together are the core of this structure. And the interesting thing is that this ends up being all conventional HTML and conventional SVG that we're generating here. So you can take a D3 generated document, kind of grab the DOM, serialize it, and just kind of paste it into a web browser without any JavaScript behind it, and it'll actually show what you were seeing before. So you don't have to, you can kind of freeze the state, turn the JavaScript off, save it out, and use it elsewhere. Which, considering you're using it in if you're using the SVG form of it, it's actually it would be really handy for generating figures for papers. So this is a example of this is some data in JSON. So we have account and number of topics. So this is basically a histogram. So we say that there are 44 44 things. I think what this was oh man, yeah, I think these were papers. So so there were 44 papers with no topic, 6 papers with one topic, 1 paper with 2 topics, and so forth and so on. And so what we do is we have basically we access this data and we ask for the function data, so we pass it there, and then we can actually operate on this data from within this function. So that's the callback. And when you're using the Sparkle Select function, it works exactly the same, except you have the endpoint and the query as well. And so you get, but in both cases, you get back a JSON object that you can then work with. And so this is, if we actually, so this data that we were looking at can actually be manipulated using this structure. You'll note we're talking about bodies and ULs and LIs, and basically working with HTML. We're not doing any visualization yet, but what it's doing is it's saying basically, so get me the body, and then add a UL to it, and then this select all. This is interesting because so this select all LI, there are no LIs in, well, so the UL didn't exist yet, but the LI certainly didn't exist in a non-existent UL. So, but what we've done is we've basically made a dynamic selection, and we can actually instantiate those by calling this data, which gives you the what it does. This is an array essentially. So that came in from this, which we remember, if you remember, was this. So this is just an array in JavaScript. So we're not working with anything fancy here. And so it's basically so it's setting an array that you're going to be working with, and then when you call enter, it actually makes a element that you've selected for each instance in there. And then so when you do the append, that actually generates that that element, and then you set text in here. This is just kind of building up a string sort of thing you usually see. But the interesting thing is that in a lot of these sorts of functions that you call on this stuff, like text or style or attribute, rather than passing in a value directly, you can pass in a function where this function gets called for every element in num topics. So D is one of any of the elements in num topics, and so you can declaratively describe what you want to show in LI. So what happens with that is you get this sort of thing where, as we saw before, we had 44 people. Specify 0 topics, 6 people specify 1 topic, and so forth and so on. It generates this from that structure because it has declaratively described. You've declaratively described what you want to see in that. And so if we actually generate it out full, that's actually what you see. And of course we can add, since this is a histogram, we can add bars to it. Now that's actually pretty simple to add. All we're doing is we're, in addition to adding that text, we go back and we select the body, we add a little SVG element, we add a rectangle to it, and that's this whole thing. And we set the height, the Y to be basically to align it with the actual text. And then we give a width that's relative to the count, so we just say 11 times the count, and we set the height to 20. So that basically gives you, basically declaratively adds a bar for each one at the right width.
What again does enter do?
Enter, it basically prepares a set of elements for creation based on the data.
So it's instantiating a bunch of rects in this example?
It's, well, the append actually instantiates the rects. But what enter does is it actually says, use the data to define what's actually in there. So you have to set the data, and then you have to actually use it. There's another thing called exit, because the way this works is that you're supposed to be, you're manipulating the DOM, even including existing elements in there. So you're not just blindly appending stuff into the tree. You're actually modifying things, removing them and changing them depending on where you are in the data. So if you have one array and you set that as data and call enter, you do all your stuff, and then you come back and do it again with a shorter array, it will start by, so the enter will actually kind of reserve those elements from that array. The append will actually replace those elements with this new rectangle. If you were to call exit, which is the reverse, obviously, it will actually go and remove any elements that were not in the data.
So it's not taking a step down within the DOM?
No, it is not. Not at that point. So you don't take a step down to the DOM until you call append. So the append actually will change the selection
Of the visual element?
yeah. So this actually creates a selection, but it's not. You're not doing much with it until you actually. So this starts off as basically being an empty array. You're not going to be able to do anything with it because it's empty. But this data and enter end up so it ends up assigning the data into some notional set of elements and then reserving them.
Okay.
I wish I could explain it better, but
I think I got a sense of it.
okay. And so, as I said before, these attributes. So when you set attributes, you can actually basically set functions on those attributes. So for every element, it actually calls this function and does the math and returns that value out. So you don't have to iterate to set these things to have. You can have very complex representations based on the data, but they're declaratively described in terms of these functions. So we saw that. That's actually the SVG of this. So that's actually what shows up in the DOM. So we talked a bit about select. The parent is kind of the starting point. Append is a way of actually creating elements in there, and you can just directly append new elements based on a single selection. So if I select the body and I say append H1 because I want to add the title, it'll just append one of them. But if I set the data, then it will actually go and basically reserve a certain number of spots based on that data. And then we discussed enter and append again. And so there are two ways of setting attributes. You just set a value directly. You can set, or you can set a function that gives you the value based on the data that you pass in. So this is a scatter plot. And so what we've done is I'm trying to remember which. So basically, there's two scales. There's I believe this is probably the time scale, value scale, and so you want to set. So these domains are actually the size of the data that you're pulling in. The range is the size of the display that you want to display it within. I know that's not quite the same thing as semantic web domain and range, but anyway. And then when you actually go and you select a chart element and you add an SVG, and circles so you select the circles, you add the data, enter it, append the circle, you set a center X and a center Y to give you so the CX gives you the date time, and so what it does is because we're adding these right, so time scale, value scale. So we're calling time scale to actually rescale the data for you from the domain to the range. So that's how you actually get arbitrary data scaled down to a very specific coordinate on the page. And the nice thing about that is that is just a generic thing that you could do. You can just use on your own. You don't have to be doing stuff with SVG. It's just a scaling mechanism. You can add axes to it by asking for an axis, and you pass in the scales that you've created, and then you just append those axes to your SVG, and it'll add it right in there. And it is smart enough to know what types of axes you're looking for based on the type of data that you've passed into it for the domain. You could also add a line, and so what this is basically you're setting a line with X and Y coordinates, and then you're doing that same mapping from domain to range, and you add an SVG path, which gives you with a class of line, and you pass in this. So what this is doing is that this is a function. This is actually it's setting that the output of that function as the input of that. And of course we can do mouse overs to actually get certain values. You do that using these on commands, and that's actually for very specific. So pretty much any HTML or JavaScript event you can call on to access it, and then it will call that function when you do that, and you can then have it remove that when you leave it. And it's actually very you'll note it's actually, because we're talking about SVG instead of HTML, you're actually looking at the bounds on these things are actually the shapes that you're working with. So you'll note, maybe you can't see it. Let me zoom in here. So if I come in here, so there's no tooltip. If we're dealing with HTML, it would have been a div or a span or something with a very specific box, and then the kind of the outer corners of that box would be technically in the circle, even though they're not.
Right, but that's not something specific to D3. That's because you're using SVG.
Yeah, exactly. What I'm saying is that
Once again, we're using standards.
yes, it's an advantage of using something that reusing this SVG standard. Right. So this is the summary. We actually haven't used these yet, but I will when I show you some of the next things. Because of the way this works, D3 actually does end up being a visualization framework. So before I go into some of the other examples, if you want to actually work with this toolkit, you can actually look at the API here. It's a great place to kind of get a better sense of what's going on. Tons and tons of examples, very sophisticated visualizations, some of which I'll actually show you right now. But everything's the D3 world is all in GitHub, so you can clone things yourself and start contributing back or fooling around with it. The original author of this recommends JavaScript: The Good Bits. Really, it's a short book, but also learning SVG ends up helping a lot with this, because SVG itself is a very powerful vector language that you can do some amazing stuff with. And because all you're doing is you're manipulating SVG, it ends up being much more straightforward to do really interesting, powerful things with it. So back to this visualization that we had before. It's actually pretty straightforward. So there's this force layout thing that you actually you build up. You give it some parameters, and you set the nodes on it. You give it a size and so forth and so on. And then what you do is you actually you build up a basically you build up a node class using so the JSON results bindings. So if anyone's actually used JavaScript and JSON, this is the sort of thing you get. So you get this kind of a base map with a head and then the list of variables. Then you get the results. The results have bindings, and the bindings is a list of maps where you have the variable, and then you have a entry. The entry there's the type, there's the value, or if there's the language, and so forth and so on. So this is actually the data that we were working with to generate that. Let's see here. So this is the query that we put in. And it's just you know, a person is a faux person, and has a name and a depiction of the photo. It's pretty straightforward stuff. But the basically this is generally boilerplate. You have to append a so for every node that you're going to be adding, you append an SVG, and then you set an X and a Y. This actually this kind of magically comes in from the force object, because we've set the this was supposed to be changed too. Because we set the nodes as nodes within the force thing, it's actually doing a force-directed layout, and it's using the it's actually setting X and Y on all of the data points in there. So it will actually do that for you. And then there's a force.drag that's what lets you actually move things around in here. And then you set an image by appending an image to that G. I mean, this is just kind of basic SVG stuff. You give it an X and a Y within that G, the graphic. You give it a width and a height. That limits the size that it will show up here. And then you give that image href with the value. And so this is all basic stuff that I showed you in kind of simpler context. Then you, in order to actually continue laying things out as you go, you use this tick function. So force will actually tick every now and again, which calls this, and then you give it an SVG transformation to actually map the node to its correct place. Actually, one thing I want to show you is the kind of the back end code for this, because one other thing that I found interesting is that it's actually pretty easy to customize. And so I wanted to be able to, when I click on a node, I want to go to someone's home page. So right now you can't do that. It just kind of bounces around. But rather than appending a G, if you append an A, so G is group, and then A is basically an anchor, so it's a link. So like we're normally used to seeing. What I did was I simply changed that type and I added this additional attribute. And since I have in the result, I forgot to remove the person variable from the result conveniently. I can just take that and return that from this function. And so if I save this, reload this, it might actually work. Maybe. Okay, so who's someone that I knows their thing is going to work if I click on it? Yeah, exactly. So it actually clicks through now.
Well, so in most cases that will work. For
Yes, I
people
know.
who have external FOAF files,
Yes.
they have to set it up so that it 303 redirects when you ask
Exactly.
for HTML
So,
or XHTML.
Because of a lot of hard work by Evan and Patrick, it clicks through.
If you had like an RDF system that was crawling these links, it would actually get the RDF back. Because
Right.
that takes you to their instance URI, not to their...
Like that?
Yeah, like that.
Exactly. So, for another presentation, I actually needed to learn how to use box plots, so I decided to give this example as well. It's a little bit more complicated. It uses an CSV, because this actually was a survey that I posted in Google Docs and then just downloaded the CSV to my page. But you can build a box chart, give it whiskers with a particular interquartile range, give it a width and a height, and so forth and so on. You basically you iterate over the data to give it to build it up into the expected array, and then you just style it as needed, and basically place it in there. But this is actually all. These are not graphics. This is actually all SVG. And that's it. So if anyone has questions or wants to experiment with this, we can do that. And unless, does anyone online have any questions or want to keep this up? If not, we can just switch over to kind of general stuff.
What I'm guessing is a stupid question. You can only use this with select statements, right? You can't use a describe.
Sure you can.
Good.
Well, so, let's see here. The, so sparkle.js. Right now I created, so these are not complex functions. Sparkle select simply builds the URI and then returns the JSON. Sparkle construct simply builds the URI and returns the JSON. So you can, I can very easily, actually I think you could probably pass a described query in here, and it should work because it's expecting the same things back. No.
But any other endpoint that does.
Right. Yeah, and the only reason why I'm using Sparkle proxy here is because of the whole redirect thing. So the TW endpoint isn't set up with to respond with JSON-P, which is this weird callback thing, which allows you to get around the cross-site scripting restrictions that exist in JavaScript these days. Yet another frustration that I have yet to, I understand the intentions behind it, but I don't understand the implementation behind it.
Can't you just do like a JSON-P type thing?
Mm-hmm.
Normally
That assumes that JSON-P is not...
Just like you were using doesn't
Yeah.
Oh, really?
Mm.
I didn't know that. Okay.
It might be supported.
I think it might be. I don't know if it's a virtuoso, but I would
The
imagine.
other thing we can do is you can probably set it up so it just returns the appropriate header for the, what is it, all access content allow wall or something like
I've tried, and it's just, yeah, they're weird. It ignores, like, I think it has to be on the server side. So if you're actually
Right,
requesting,
that's what I'm saying, we can update the endpoint to,
yeah,
to return that.
right,
Yeah, because the browser asks, and then if the endpoint doesn't return anything, the browser ignores it. Unless it's
Right.
old enough to not care. In which case
right. But to me, it's very strange that so if you're injecting code into a web page, and the web page, and that code is calling out to somewhere else, chances are it's calling out to somewhere else that's malicious. And so if you're doing that call, it's not up to the server to determine whether or not you want to have data being sent out or pulled back. It's up to the client. And so having the client ask the server for that just seems really strange to me, because if the server is like I said, if the server is malicious, if what you're trying to prevent is the ability to access arbitrary data from an unknown server.
Well, it's more so if I inject a script into your website that tries to read your Facebook profile, right? My script comes from example.com and attempts to make a call to facebook.com, it will be blocked. Right. As one possible situation that I prevent.
It could just as easily request, or it can just easily try and get some cookie data and
Right, it could
do
But-
it out of band.
I think most of the newer browsers will also prevent it from accessing cookies that aren't originating from its domain. So.
Either way, I have not been a web developer, and so some of this stuff is just, like I said, it's just a little bizarre to me, but I'm sure there are good reasons for it. So anyway, anything else? Yeah, but you'll note there's not really anything that's that special there. I did add, there's some other stuff that I have in here so if you do a constructor describe, you can add it to a local graph, and all this does is it basically it takes the JSON tree and turns it back into an object graph in memory. So if you have something that's pointing out, so if you say, Jim knows Tim, it's actually using the strings, and it's using URI strings on either end of that statement in the JSON. This will go and instantiate objects and point directly at the objects rather than having to relook up the URIs on either end of a statement. So it makes it look a little bit more like a regular object in JavaScript it is if you built it locally. But that's I don't know. I didn't actually use it in any of these demos.
Are you going to have these slides on the board on your GitHub?
Yeah.
So you learned JavaScript just for this.
Pretty much.
And were you happy using JavaScript for this?
I'm going to start using CoffeeScript, which is a modernization of JavaScript. The problem is that CoffeeScript is a language that's compiled into JavaScript, so you have to have the tooling, and you go back to a compile run thing, and without that, it's pretty simple. But a lot of it's been it was mostly seeing the simple examples that have been on the D3 website and saying, oh, I actually understand this. I know what this is doing, and to be able to keep going with that, I haven't been able to do that with a lot of JavaScript that's out there on the web. Both, certainly the stuff that's called out as being terrible, but sometimes even the stuff that's called out as being good just doesn't make a whole lot of sense to me.
So what about using Google visualizations versus this? I was talking to some students, not in this room, the other day, and saying that I thought Google visualizations was a little bit easy to get started with. Would that have been your experience? Say you knew JavaScript to begin with.
Yeah. Well, that was part of the thing, is that I didn't find the Google visualization toolkit to be especially understandable. There wasn't a whole lot of, so I mean, it was basically, here's some data, and it's in a format that you better get right, and here's the graph for it. And there's no flexibility in terms of that. And so I found whenever I tried to take one of their examples and extend it into something else, I ran up against the wall. And it could be just because what my expectations were about what I wanted to do with it. It could be that I wasn't formatting the data correctly. It could be a number of things. I also wasn't nearly as versed in JavaScript first when I started with Google Viz. But supposedly that it's supposed to be good for people who aren't that strong in JavaScript.
Yeah, they kind of serve completely different purposes. You know, Google Viz kind of tells you exactly the way it needs things and doesn't give you the options to customize, because doing that would require a much more verbose and kind of complete library like D3 is. So they're kind of the spectrum of visualization libraries. Ones that you just throw data at and it makes pretty stuff, but you can't really modify or change the properties or options or configurations of that. Or you can do something where you build almost everything on your own, where you're programmatically telling every piece, I want it this to be this big, I want it over here, I want this color, etc. And so it's where you fall in that spectrum and how you want to play that kind of determines what.
Yeah, and I started off I didn't start off, but I spent a lot of time as a Java Swing developer professionally, and so this worked a lot more like what I expected things to work, as opposed to Google Viz toolkit. Because I've also used a lot of visualization libraries in conventional Java and Swing, and it's this was, like I said, this was the first thing that I saw that actually beat some of the stuff that I had been using in Java previously.
Thanks.
Any other questions? Do you want to,
Do
anybody do some examples, or? No?
Yeah, I think maybe if we went through maybe if we could actually go through a whole example or make a new small visualization and go
Okay.
step by step, maybe talk about the design decisions or some of the ideas of what's going through your head as you're thinking about some of these to learn a little bit more. Because some of the places where I'm confused in maybe this is just getting more comfortable in the more kind of functional side of this. So, having just dynamically having functions that have, to me seems like arbitrary parameters, not understanding how that relates to other things going on and where that mapping is. Is that important? Is that something I self-define? And so when I've been looking at this stuff in the past, that's where I've always been stuck at understanding.
So there's just one vote for this for the tape. We really just want to go through one example.
Yeah.
So that people with a little bit less training can watch the tape.
Right. So is there?
Drop a plug for loudspeaker, and how that would be able to allow you to
Yeah.
those.
So yeah, actually, does anyone have the research demos loudspeaker page off the top of their heads?
I have the coordination gauge.
Okay. Okay. You can just Skype it to me.
So what you did for these demonstrations was implement your own Spark recording.
Yeah.
If you, so D3 wants some JSON file with that array of those data elements. What you can do using loudspeaker is basically tuck away that Spark recording and do that on the server side. And if expose that as your traditional Web 2.0 REST call that will give you the JSON itself, so that you've completely hidden all of the Sparkle query, which could be viewed as nicer from a traditional web developer side. But once you start hiding Sparkle queries, I start to get a little worried. And this research demonstration does that. It queries against LodSpeaker with just a normal service URL request. And then on server side, executes a Sparkle query, formats it into the JSON, and sends it back to a D3 friendly JSON.
Right. So the actual page for this just has the HTML part in here, and then it calls this force.js, and so there's this chart that's been floated right, and that ends up being manipulated by force.js. It'll actually help if I... Oh, what the heck. Resource. Right, so... Let's see if it actually... Right, so what this is doing is it's automatically generating the JSON for you with some of the data that is useful. And basically, well, this is actually a pretty complex thing, but essentially what it has done is it's just taking that data from the Sparkle endpoint and mapping it in there. Now this is a complex visualization, and it's complex on the back end, but it's useful to see. So, but I mean, the thing about LodSpeaker is that if you have a pile of linked data, this will let you. This will get you to the point where you can start doing visualizations easily just by plugging in this this stuff from plugging this stuff into D3. But oops. So let's look at some of the more simple examples. Does anyone have any opinion about these? I'm just going to scroll through them slowly. Just call one out.
I don't know, any of the mapping one would be pretty cool. So I'm gonna have personally like map visualizations and
Like this
better
guy?
ways to do them. Yeah, sure. Yeah, I would love to do something like this. Yes. But I've been trying to hack doing stuff like this in other library kits, and it's always worked terribly.
Yeah. So essentially what this is doing is it's so there's a standard stuff for building a chart, but then this path, you use this path to actually map from geospatial coordinates into your chart.
So that's something that's kind of just baked into D3?
Yeah.
Okay. Is that taking, what kind of assumptions do you, I don't know if you're familiar with it all, any type of assumptions it's taking on projections, stuff like that? So I'm assuming I just can't use like any map type like SVG on this, it'd have to be the one in the right projection that library or something is assuming.
Well, so there are a number of projections you can use.
Oh, okay.
This was so this is actually just the lat-long state and county boundaries. They did some simplification of them, probably just to make it easier to render. But pull up another page here. So as I said, the API reference is really phenomenal. But so the, hold on, geo. So there's this, the geo path, which has a default projection, but you can actually modify the projection using any one of the things that are in here. So there's Mercator, Albers, Albers USA, Azimuthal. I guess those are the only ones. But so essentially, you can pick how you want it to be put together. Since it's using the default one, it's not actually showing it here. So we basically added 2 groups, one for counties, one for states. And then what we do is we load.
Are those adding things, or those are things already existing in this SVG that we're borrowing? So there are things in this are there things in the SVG? Are we actually creating this SVG? Is this one we're borrowing from someone?
Creating the SVG. So when we did,
okay.
so when we did this, append,
yeah.
we created this SVG from scratch.
I see. Interesting. This is absolutely fascinating.
You don't actually load the data until you get to this
Right.
US county.
So this US counties .json actually has the has, among other things, the shape, the geometry right in there.
Okay, that's really cool.
So I mean, you can project whatever you want onto it.
Yeah, no, that's awesome.
And since that's a lat long, so these are all just lat longs, I think. Yeah, they are. And then you map, so you create a path. Let me think here. So you do so you create a bunch of paths using the select all, data, enter, append path, and then you give it. Where does quantize come from? Ah, yes. So the class is actually set via this quantization thing. So it's actually taking. I thought I. Right. So there's I think these ID. Is that what they're using? Yeah, data.id. So it's basically creating a. Let me show you that down there. So it's taking this value. I mean, you could put any value in there, too, and the quantization is what gives you the color, because it's setting. It's setting this class based on that, and then we have the D is the actual path that's being added. I'm trying to think of where exactly that. Yes. So basically, you build this path, and then the features is features data path. It may expect the coordinate the type. So to be to have geometry of type polygon in there, looks like. And then it does the same thing for the states. And then this unemployment data is actually what I think is what gives you the value for it, because you're kind of reselecting the paths and then giving that quantized.
Is there a reason why they're doing counties first and then states in terms of building this SVG and the structure of that? Or is that just
That's because it's
You're
about
gonna create
Z,
that hierarchy?
it's Z ordering.
Yeah, so as you add elements
Yeah.
towards the bottom are on top of the things that are.
I see. Yeah. Okay, that makes sense. Yeah.
Otherwise, all those white lines would be hidden underneath the
Right.
county.
Yeah. Yeah.
Okay, so does that make more sense to you now?
Yes.
And so in his CSS, he's just defined a bunch of Q number classes to represent the different,
Right.
Oh, so that's the actual the gradient thing of
Yeah.
figuring out from the values I'm getting what gradient of color I should be using.
Right, so I'll bet you if we look at the source for this, there will be a chloropleth.cs.